The problem that we have today is to calculate the optimum number of clusters for a given data. So the data that we have been given will be imported using the import dataset functionality that we have been provided here and browse to our dataset, that is iris.csv file, and it will show the data preview here, that in how format our data will be loaded. It will be similarly reflected here with the species, petal width, petal length, sepal width and sepal length. Now calculate the number of clusters we will be using k-means clustering, and for that we will include the species column as in any calculation only the numerics will be used. So we will remove them. So for removing the column, we will create another data file, that is iris.usecase, which will contain all the properties of iris library, iris dataset. And now we will remove the column that we want to remove, that is the species column, using the null function. And now as you can see here also that a column has been reduced, and just to verify we can also use view function for the iris.usecase file and see it here that our species column has been removed. Now to go further, we will include some libraries that we will be using in this project, that are ggplot for plotting the graphs for the dataset that we will be having, and then a library for performing the k-means clustering and other forms of calculation, that is the factoextra, and a library npclust to create the clusters. Now we will create a Now we will scale the data to perform the k-means clustering in a file naming res. And now using the scale function to scale the data that is stored in the iris.usecase file, and you can see here that the data has been scaled. It can similarly be seen here using the view function for the res file, and here is the value that we all have for the id, sepal length, sepal width, petal length and petal width. Now we will be performing the k-means clustering using the function fviz and bclust, and the data frame that we have is the res, the scaled data, and the x-intercept that we will take will be 0, so as to get a clear and understandable picture for the dataset. And here you can see that the elbow that is being created is at 3, and the difference between 1, 2 and 3 is quite large as compared to 3, 4, 5 and for the values for the right number of clusters. Now we will with the use of this elbow method we can say that the number of optimal clusters will be 3, and to check even verify it, we will perform k-means clustering for all the three values 2, 3 and 4, so that we can see the difference between the graphs plotted and the values that we receive. To perform k-means clustering, we will use k-means function, and this k-means function will be stored in the file called result file, and the k-means function will be applied on the dataset res that we have for number of clusters 2 first. Now to see the properties of this k-means clustering that just happened, we will type in result and see the properties here. As the cluster means for id sepal length, petal width, sepal width, petal length and petal width have been given, and the clustering form is the two clusters formed are quite vague. One is of 50 and the other is of 100 values, which will be the vectors have been reflected here. Now we will store this. Now we will store this data in a now the scaled file that was created res for the calculation of this k-means clustering will again converted into a data frame here, and the data frame will be called as results, or we can say that it's result 2, which will contain the function as dot data dot frame and contain the value of res, and here the data frame has been created, as you can see here. Now we will be using the ggplot function to plot the graph for it, and result 2 is the table that we have to plot with the aesthetics. Result 2 is the graph that we have to plot, and the result dollar cluster will create the clusters according to the will create the cluster according to the number of clusters formed in the function. And result 2 will be the data for which the function will be plotted. And here you can see the graph that two clusters have been made. One is for the smaller value of 50 that was created here, and the other cluster is of 100 values, and this distribution is quite vague, as we can see that there are a number of clusters here and here. All there are two different clusters here and here for different values ranging from 0 to 1 and 1 to the next value. So to check whether now we will be performing the k-means clustering for 3 clusters, or first we will perform it for 4 clusters, just performing the wrong ones and the same, and now again checking for the results. It will give us different results like this. Here you can see if we print out result here, if we print out result here and check that the 4 clusters that formed were, first was 47, 24, 26 and 53, and here we can see that the 24 and here the values have been mixed up quite more, as you can see that from 1 to 47, 2 3 clusters have been mixed up, which is this well area, and the next values from above 50 have been the cluster 4 and cluster 3. Cluster 1, as you can check it from the graph scale here. So this clearly shows that the values of the number of clusters 4 and 2 are not the perfect solutions for us. So we will perform k-means for number of cluster 3, and we also know that the number of cluster 3 will that number of clusters equaling to 3 will be the perfect solution, as we know that we have three kinds of uh, species in the data set. And here we perform the k-means clustering, and just to check out the result we will print out the results. Here you can see that three clusters have been formed, first for the 53, second 50, and third 47, which is quite good, as all the values have been as all the values are quite near to one another, and it can be experienced here also, as all the values are approximately the same. Now we will print out the results here using this ggplot function, and you can see the results clearly that three different clusters have been formed perfectly, which clearly shows us that this is the perfect solution.